style. Okay, so yeah, good morning. I'm going to talk a little bit about kind of what is AI and machine learning to kick off, and why deployment matters. So that's really where we focus at machine learning. AI is not something that has arisen as a topic in recent years. We've been talking about it for a very long time. This gentleman, I.J. Good, who was at Bletchley Park with Alan Turing, in 1965 said, the first ultra-intelligent machine is the last invention that man ever needs to make. Some of you may recognize this from Tim Urban's Wait But Why blog. Obviously, scientifically accurately drawn, but what he's trying to really explain here is that where we stand right now, due to the kind of exponential increases in compute power, availability of data, R&D in this space, and you may think about it as the sort of lawnmower man singularity effect, but actually there are other explanations for this. So as most technologies emerge, they kind of follow like an S-curve, and when they reach the sort of point of adoption, they kind of plateau. And what AI and automation enables is effectively the line here of adoption to just continue going upwards and effectively form a J-curve. This is responsible for a lot of the exponential increase in human progress. The AI not just plateauing in sort of 2025. So this is really one of the big drivers of the fourth industrial revolution, and it's really already begun. So really, what is AI? There's the kind of Hollywood sort of Terminator view of strong AI. There's kind of like over anthropomorphized view of sort of sentient beings, and then there's the sort of real practical AI that we see in the world today, which is very narrow and solving very specific problems, but actually doing that with sort of superhuman capabilities. AI obviously covers a broad range of different topics, and really, when I think most people are referencing AI, they're really talking about machine learning, within that deep learning, so neural networks, and reinforcement learning, where you have agents which are effectively learning like humans learn through kind of a reward mechanism. So obviously this adoption of machine learning and AI technologies will have a significant impact on jobs, and we're going to go more into that in this discussion. But the real core drivers of it, other than the compute power and availability of data that we've discussed, we've been big believers in open source software, and we've seen a significant increase in open sourcing since Seldon was founded in 2014, with the emergence of technology projects like TensorFlow from Google, with PyTorch and many others. And there are other growth accelerators, obviously driven by improving products and services, the increased investment going into AI, and actually AI is now a national topic. It's not just something which is sort of a niche isolated thing among researchers. It's been driven and invested as a priority from the very top of UK and international governments. Obviously you see a significant amount of investment in China and the US. So what is machine learning? How does it differ from traditional programming? So with traditional programming, you are handcrafting your rules and algorithms. You usually have some data as an input, and your outputs allows you to fulfill some certain objective. With machine learning, the input is your data, but also the expected output. So effectively labeled data, in most cases, is what you're feeding into the machine learning algorithms, and the output is a program, but it's a very special type of program, which is what we call a model. And one of the exciting things about machine learning is how it amplifies the traditional network effects that you'll all be familiar with. So, as more nodes are part of a network like the phone system or a social network like Facebook, the network as a whole becomes more useful and has greater defensibility. With machine learning, there's a data network effect. So as more people join the service, the actual service itself improves, not just as a sort of byproduct of the people using it. So for example, Google Images will have a much better, Google will have a much richer set of data for general images, but maybe not so for medical imagery, for example. We hear a lot in the news about some of the sort of more negative sides of AI, and certainly there are some out there. It's important that there is discussion and regulation in some cases. It's crazy, obviously, to consider that the manipulation of people on social networks has actually impacted global politics already. There's massive investments in facial recognition in China. Actually, the largest AI company in terms of investment in China, SenseTime, is focused on facial recognition, and we're already seeing the police walking around with surveillance glasses. So it's a brave new world. This mind-reading alter ego is another interesting case study, which actually could be used for good as well, for better accessibility for people with disabilities, by using bone conduction to enable you to communicate and control devices. But there's a huge amount of good that could be done with AI as well. This is just one example in medical imagery. There's a company called Butterfly Networks based in Connecticut, which has created a device, probably not much bigger than this clicker, which plugs into your iPhone and enables you to do a live ultrasound on a patient, and it gathers the imagery from this very, very small ultrasound on a chip like this, and enables the doctor to not just do the scan, but also diagnose the patient in real time. So this is important, considering that most of the world doesn't have access to even the basic medical imagery, but then there's also the skills of people who are able to interpret those medical images as well. So massively reduces the cost to under $2,000, which is 20% of the cost of this giant fridge-sized machine that people have been using previously. Obviously AI can be used across a significant number of use cases other than medical imagery and all the nefarious use cases we mentioned earlier. It's now proven technology, so this is some research from McKinsey that shows a small number of techniques are being applied across industries and have given on average a 62% incremental value above even the previous generation of techniques. This means that over the next few years, millions of models will be produced, but the problem is putting those models into production requires highly specialized skills and infrastructure. So it's not just about building a model, it's about building out this full production pipeline so that you can actually feed your data in, train models at scale, and then serve them, optimize them in production to ultimately optimize your business KPIs. So this is where we focus at Seldon, and we'll talk more about this. I'm just going to hand over to Clive quickly to explain containers. So it's our CTO, Clive. We'll just do a couple of slides on...
Cheers, thanks. So I'm just going to explain some of the foundational technologies that we use at Seldon, how we build our stack. So one is containers. Obviously that's been made popular by Docker. So if you don't know what containers are, just the core thing that it solves for us is really it's making the software reproducible. So all your dependencies are put into one package, so you can take your software, piece of software, and give it to someone else, and it's going to run the same way. So obviously before that it was a huge pain. There were other technologies, but Docker's really solved that. Or containers have solved that. Docker's the most popular version of that. That's one aspect. The other aspect is very lightweight, so it means you can get different software running on the same machine, hopefully isolated between them, which means you can have some multi-tenancy and that's another key aspect of what we're moving towards. And all these are obviously important aspects towards machine learning as well. But even a machine learning app, it's not just made out of a single application. You need to build several things together to work well to do that. And so you need more than just containers. So there's technologies that come on in the recent years, last 3 years, to actually orchestrate containers. So take multiple components of your machine learning app or other apps in general, allow you to combine them together. And one of the most popular is Kubernetes, and that's what we build on top of. It's probably the market leader in this area. There are other competitors like Docker Swarm, but really even those have started to support Kubernetes. Has really come out top. So it came from Google about 3 years ago. It's now completely open source, and now it's completely separated from Google. I've actually gave some $9 million to the Kubernetes project so they could spend it as they wish to actually further develop it. So it's completely separated out now, so it's not connected to Google. So what it allows you to do is to choose and describe your infrastructure that you want to run your app. So that machine learning would be things like GPUs, and you know, so this model is GPU, this needs a certain amount of disk, to describe the networking, to describe the security, all the things you need in any application, but definitely also machine learning. But it's complex still, you still got to describe all that, and you've got to manage it, so there's still a lot to do to actually get a final solution. So we're trying to build on top of that to make specifically for machine learning, to actually solve that task, to build on top of these technologies and make it really easy for people to go from their model and all the stuff that we showed in those boxes to actually deploy your model in production. Because what we don't want people to do is to fail and just have a POC with a machine learning app, but not tie it to the real business where it's actually going to make a difference. So you want your data scientists to do the cool stuff of building the model and working on the different algorithms. Once they've done that, you want to deploy it out to production and then keep iterating. That's what people forget. You know, they do the model once, but then you've got to keep it in production. You may be creating a model every day, and it's got to be rolled out smoothly. So these are some of the goals at a high level that we're trying to solve with Seldon Core. These are open source products. One is every way to actually deploy apps. So different ways you want to actually deploy them out into production. So you might do rolling or canary deployments, where you try out a new model just on a small amount of traffic and then send more traffic if it's working okay. You might do blue-green, where you set up a big set of deployments one side and then set up the new set the other side and switch between them. So all these options, we want to give people the choice to do that and focused on machine learning and then to deploy out quickly so they don't have to worry about these things. The other thing we want to do is everything to do with optimization, so allow them to actually save money, obviously. So machine learning apps can be expensive. You're using GPUs and other things which cost a lot of money. So you want to obviously use the smallest amount of infrastructure to get the biggest impact for your actual model. Other aspects of optimization, low latency. So obviously we work in the financial sector. Sometimes it's very low latency. You want to optimize your throughput for your machine learning app. So allowing data scientists to get that maximum throughput for their app. We want to focus on making that easy for them. And also optimizing between different models. So you might have a new model that the data scientist has created, which is completely different technology. Maybe one's a neural network, one's a random forest. How do you put those into production and optimize and send traffic to the best one really quickly, so you don't have to, so you can put them out safely as your data scientists iterate through the models. Secondly, you need to tie your machine learning into the business, so that means you need to connect via some APIs. So we allow that to be done automatically via different APIs, gRPC and REST, and further ones we're also looking at ways to do that. So you can just send it out there, your app, your machine learning app described, and it will connect, and then your business can connect to that machine learning app really easily. And finally, we want to allow all forms of management, so auditing of your app, so you can check what are the changes between the last version that the actual data scientist created and what are the differences. You can then go through like a clear like approval chain, so that various stakeholders that need to verify before you actually put the app out to production can verify that. And all forms of making this like sort of continuous integration. So there's some ideas from CI/CD in terms of integrating that automatically that we're working on sort of specifically for machine learning to make that all automated, but then tie in the actual approval process as it goes along. So really what I'm trying to say is there's a lot of things you've got to think about in machine learning in terms of putting these models into production, and we're trying to solve that and make it easy for data scientists. So this is our open source base, and I think I'm not sure we might talk about Seldon Deploy, which is our enterprise app which we're working on now to see about that.
Great, thank you, Clive.
Thanks, Clive.
So I'll just summarize these two. So we've been really open source, and community has been a really core part of everything we do since day one. And we've seen that that's generated a significant amount of traction on our open source product. And we also host the TensorFlow London meetup, which is the UK's largest TensorFlow community. Right here at Rise, we'd love to see you guys or some people you work with at that event. And one of the things we've seen this year is that we've formed some really exciting partnerships with other open source projects. So it's definitely worth taking a note of Kubeflow and checking out this project from Google, which basically provides an open source ML infrastructure for the kind of end-to-end ML pipeline. So not just the serving bit, the whole thing. And their objective is really to provide like a scaffolding that allows you to piece together your own sort of custom stack with different components from different open source providers. So they're not trying to force people to use Google technology through the entire stack. They're actually working with best-of-breed open source technologies like Jupyter Notebooks, projects like Argo and Ambassador. And for model serving, there's TensorFlow serving, which is part of the TensorFlow project, which works well for serving TensorFlow models. But Seldon was chosen by Google as a sort of alternative to TensorFlow serving for because of our ability to serve models from multiple frameworks and not just TensorFlow, as well as some other advanced capabilities around how we run experiments, etc. So we're really excited about this project, and it's been some of the other collaborators on this include some of the world's largest technology companies. It's not just Google, it's people like Intel, Cisco, I think Microsoft are even involved, and companies like Uber. So it's one that I think will become a standard around ML infrastructure, and we're seeing kind of on the back channels that a lot of companies that have invested heavily in building their own custom solution like this are kind of scrapping it and replacing it with, planning to replace it with Kubeflow. Okay, so on that note, I'm going to hand over to Lee to talk a bit more about AI in finance.
Thank you, Alex.